Now that we've talked about polynomials, how you factorize them, how you find the quotient using the quotient is just a number that you find after dividing, how you find it using long division or synthetic division. Now let's solve some questions, exam questions. So our first question is given that f of x is equals to x to the power 3 plus kx squared minus 2x plus 1 gives the remainder k when divided by k minus x minus k. Find all possible values of k. So what are we going to do? We are being told that when we divide, it gives us a remainder of k. So our remainder in this case, we're saying is k, okay? Then the remainder, how do we find the remainder? We say the remainder of this whole expression, okay? Now we are saying it's when it's divided by x minus k. Okay, x minus k in this case is in this case, let me call it the divisor because we are saying it's divided by k. So we're going to find the x because it's a linear function. So we're going to say x is equals to k, okay, in this case. So now what are we going to do? Our remainder we've been told is k, okay? Our remainder is k. So where there's r, we put k. So this will be k is equals to our f of x is this expression, okay? So what are we going to have? We're saying x 3 plus that is kx squared minus 2x plus 1. So now what do? We say k is equals to, we've said x is equals to k, right? So wherever there is x, we're going to be replacing by k, okay? So let's just do that. So we have k to the power 3, we have k to the power 3 plus that is k multiplied by k. So that is k, where there is x again we're replacing k, so that is k to the power 3 to the squared or minus, we have a minus 2k plus 1. Okay, so k in this case is equals to k to the power 3 plus k multiplied by k squared, that will just give us k to the power 3 minus 2k plus 1. Then what are we going to have of k? Okay, so we can just put the like terms. Okay, we can put the like terms. Okay, we can still solve. So we say k is equals to k squared plus k squared, that is just 2k, k to the power 3 plus k to the power 3, that is k, 2k to the power 3. Then okay, we have negative 2k plus 1. Okay, when you take the k to the other side, what are we going to have? We're going to have a negative k. So let's put a 0 here is equals to 2k to the power 3. When the k goes on the other side, becomes a negative. So negative k and this negative 2k, we're going to have a negative 3k. So here we have negative 3k plus 1. Now you're able to see that this is a quadratic expression. Now you can either solve it using the the long division method. You can solve this using the what we call this the formula method for the quadratic expression. Okay, so now that we've reached here, let's try to find another factor, okay? And a factor for a function or an expression should give you 0. Or this is a polynomial actually, because it's raised to the power 3. Okay, so you have to first find the factor. So we're going to do trial and error. So let's pick our factors. Let me say our factors in this case, you can either, the most common ones that you can pick is positive or minus 1, positive or minus 2, positive or minus 3, positive or minus 4. At least try these ones in this expression. If it gives you 0, then that answer is it's a factor. So let's try 1. If we say 2 to the power, this is 1 to the power 3, minus 3, 1 plus 1. What is it going to give us? This is 2 minus 3 plus 1 is equals to 0. Okay, 2 minus 3, that is a negative 1, plus 1. Okay, that will just give us 0 is equals to 0. So we're able to see that 1 is a factor for this expression. Okay, so how are we going to write that? So we're saying 1 is a factor, so it will just be k, in this case being a factor, just equals to 1. Okay, now how do we find other factors? How are we going to find other factors? Allow me to rub allow me to rub this expression. Now to find other factors, you can use long division or the synthetic method. But in this case, let's just use the synthetic method. Yes, let's use the synthetic method, it being a simplest one. So what are we going to do? We've said we've picked k is equals to 1, so k is one of the factors. So let's divide it into, okay, let's use our synthetic. Okay, so we're going to get our factors, the coefficients of this polynomial. Okay, so you're able to see that the first one is 2. Okay, so it's 2. Now the second one is 3k. Now, like we earlier said in most of our videos, we said you have to make sure that the powers of x are decreasing. Okay, so in this case it will just be 0, then that's when you put your negative 3. Decreasing, I mean, in this case there should be like k squared, minus like 3k squared, or k squared. In this case, let me just put 0k squared minus like 3k, like that. This is 1. So they should be decreasing from 3 to 2 to 1. Okay, so make sure that you do that. Otherwise, if you don't do that, your answer will be wrong. Okay, your answer will be wrong. So this is negative 3 and 1. Okay, so now how are we going to do? We said always put a 0 here. So what are we going to do? 2 plus 0, that is just a 2. Then your 1 multiplied by your 2, you're going to get a 2. Then this, when you add them, what are you going to have? You're just going to have a 2. Okay, a 2. Then again a 1 multiplied by a 2, that will give us a 2. Okay, negative 3 minus 2, that is negative 1. 1 multiplied by negative 1, that is negative 1. Okay, this is giving us a 0. Okay, so now how are we going to write it? Okay, this will just be 2k squared plus 2k minus 1. This is another factor. Okay, this is another factor. Okay, so our factors, let me just write them in the corner here. We had k is equals to 1, so in this case k minus 1 is a factor. We also have this expression. Now this expression, we also have this expression, actually the quadratic. So we have to solve this quadratic expression and find other values of k, because we're trying to find all the possible values of k. Okay, so we found that k is equals to 1, the other ones. So let's solve the quadratic. Let's use the formula method. Okay, let me use this another board. So what are we going to have? We have 2k squared plus 2k minus 1. Okay, so now how are we going to find the factors? We've said one of the factors is k minus 1. Then we also have this 2k squared plus 2k minus 1. This is another factor. Okay, now how do we find the other factors? This one we solve it using the quadratic. So you know our quadratic, we just say k is equals to negative b positive or minus the square root of, we say b squared minus 4ac over 2a. Okay, so k in this case will be equals to negative, our b in this case is a 2 positive or minus the square root of b is still 2, so 2 squared minus 4. Our a in this case is also 2 multiplied by our c, which is 1 over 2a. Okay, k is equals to, okay, allow me to use a different color. So we have a negative 2. Okay, so what do we have? When we say 2 square, that is, you know, like 4 minus 4 multiplied by 2 more negative. Okay, when I do that, let me just punch it on a calculator. That is giving me the square root of 12. Now the square root of 12 can also be written as, okay, so we have a positive or minus. The square root of 12 is just the same as, you know, if you have a square root of 12, this is just the same as root 4 multiplied by 3. Okay, the square root of 4, that is 2, so you have 2 root 3. So that's what we're going to write there. So 2, you have a 2 and 3 over 2a. Our 2 multiplied by our a is 2, so 2 multiplied by 2, that is a 4 down. So okay, so now what are we going to have? Okay, we can just even, okay, so we have negative 2 positive or minus 2 over root 3 over, we're saying 2 multiplied by 2, right? Okay, so what are we now going to have? Okay, let's factorize on top. So let's factorize, and we say let's factorize a 2. So we have a 2, remain with a negative 1 positive or minus the square root of 3 on top divided by 2 multiplied by 2. Okay, these 2 and the 2 can cancel, so our answers will have one value of k will be negative 1 positive the square root of 3 over 2. The other one will be negative 1 minus root 3 over 2. Okay, so these ones will be the possible values of k. So we have k, with k is equals to this, we've got k is equals to that, and also have k is equals to 1 from this expression. Okay, let's solve another question. Are there any other exam questions? Okay, when the polynomial x is divided by x minus remainder is k, find the possible values of k. I think this one is same as this one. Yes, they are the same. So have you seen? So in different past papers, you know, questions sometimes are repeated. Okay, so now let's solve another one. Let x minus 2 be a factor of that polynomial. Find the relation between a and b given that the remainder when f of x is divided by x minus 3 is 10. Find the values of a and b, hence factorize completely. How are you now going to solve this one? Okay, so the remainder, what we're trying to find a relation between a and b. They've given us a factor. They say x minus 2 is a factor. Now if x minus 2 is a factor, you remember that if it's a factor, the remainder is always equals to 0. So say remainder is equals to f of x. So the remainder will be 0, right? Okay, is equals to, then x, because this is linear, so we're going to equate it to 0. So it will just be x is equals to 2. So wherever there is in the polynomial f of x, wherever there is x, will be replacing by 2. Okay, so we have, what are we going to have? We have 2 to the power 3 minus 2 squared plus, we've got a, okay, we have a 2 there plus a b. So what are we going to have? Okay, 0 is equals to 2 to the power 3, that is 8, minus 2 squared, that is a 4, 2 multiplied by a, that is just a 2a, plus b. Okay, let's make b the subject of the formula. In this case, what are we going to have? your 8 minus 4, that is just a negative 4. Is it? 8 minus 4, that is a 4. Okay. Okay, 8 minus 4, that is a 4. So let's say, okay, we've got 0 is equals to 4 minus plus 2a plus b. If we make b the subject, these two go on the other side, they become negatives. So in this case, our b will be equals to 4, actually negative 4 minus, let me just write it nicely. We have negative 4 minus 2a. Okay, so this is the relationship. We're trying to find the relation between a and b. So this is the relationship. B is equals to minus 4, minus 2a, like that. So that is the relationship. Then the second question says, given that the remainder when f of x is divided by x minus 3 is 10, find the values of a and b. Okay, allow me to wrap there. So how are we now going to approach this one? So they've told us the remainder x minus 3 when they're given that the remainder when f of x is divided by x minus 3 is 10. Okay, find the values of a and b. So it's going to give us a remainder of 10. Okay, so this is a linear as well. So what are we going to do? So x minus 3 is also linear. So we're going to say x minus 3 is equals to 0. So x is equals to 3. Okay, then since they're saying, so remainder will be equals to f of x. So they're saying the remainder in this case, it is giving us a remainder of a 10, like that. Okay, it's giving us a remainder of a 10. So where there's r, we're going to place 10 is equals to our f of x. In our f of x, we found that x is equals to 3. Wherever there is x, we're going to be replacing by 3. So we have 3 to the power 3 minus 3, this is squared, okay, plus a and the 3 there. Then you have plus a b. So 10 is equals to 3 to the power 3, that is 27, minus 3 squared, that is a 9, plus 3a plus b. Now what are we going to have? So we have 10 is equals to 27 minus 9, that is 18. 18 plus 3a plus b. Okay, then if we take the 18 to the other side, becomes a negative 18. Negative 18 plus 10, that will just give us a negative 8. Okay, so let me just do that. So here we have a negative 8 is equals to, okay, let me also take the 3a to the other side. It becomes negatives as well. So it will be negative 3a is equals to, we just remain with b. So now we have two expressions of b, this one and this one. Okay, so now how do you now find the values of a and b using this expression? Okay, so we just solve them simultaneously. Okay, so how are we going to solve them? So let's get this expression where there is b replaced. So we're saying, we're going to say negative 8 minus 3a is equals to b. And b, we've also found that b is equals to that. So we're going to just replace on the other side. So we're going to replace by negative 4 minus 2a. So now what are we going to have? We can put the like terms together, the ones with a and the ones with, okay, so let me just try to avoid the negative. So negative 2 and goes the other side becomes a positive. So and the negative 8, let's also take it to the other side, so that okay, so negative 2 will become a positive 2a on the other side, so negative 3a will remain is equals to negative 4. When the 8 comes the other side, it becomes positive 8. Negative 2a minus 3a, that gives us a negative a, okay, is equals to negative 4 plus 8, that is a 4, okay. So when you distribute the negative, or when you divide by the negative, it will just be 8 will be equals to negative 4. Now that we found that our a is equals to negative 4, what are we now? How are we going to find our b? We just get any expression. Okay, we can say, we can even get this one. We get that expression, so how are we going to do it? So we're going to say b is equals to negative 4 minus 2. Our a found that it is negative 4. So b in this case is equals to negative 4. Negative 2 multiplied by negative 4, that is a positive 8. Okay, so b in this case will just be equals to, it will be equals to 4. Okay, now how do we solve the last question? Hence factorize completely. So how do we now factorize this expression? Allow me to wrap there. Okay, so how do we find how are we going to factorize it? Okay, so we are saying this, so you just have to find all the factors for this expression. Okay, 4x plus 4. Okay, so we found that our a was a negative 4 and our b was a 4, so I've just replaced them indefinitely. Okay, so what are we going to have? So remember that they told us this expression is divisible by x minus 2, and we equated, so x was equals to 2, right? So let's use synthetic division. Okay, so we're saying x is equals to 2. Then our coefficients from this expression, so you can be able to see this is 1. We have negative 1, we've got negative 4, and we have a constant 4. Okay, so what are we going to do? We put a 0 first here. We add 1 plus 0, that is 1. 2 multiplied by a 1, that is just a 2. Negative 2 plus 2, negative 1 plus 2, that is a 1. 2 multiplied by a 1, that is a 2. Negative 4 plus 2, that is a negative 2. Negative 2 multiplied by 2 multiplied by negative 2, that is a negative 4. Okay, negative 4 plus 4, that is just a 0. Okay, you're able to see that this is a factor. Okay, so that's one of the factors. Then how are we going to find the other factors? Okay, I think this one we can, so how are we going to find the factors? So let's first write this expression. So this will be x squared. We always drop the power of x. There's a 1 there, so plus x minus 2. So this would be our answer. So this is one of the factors, and the other factor is the one that we're dividing by, which is x minus 2. Now this is a quadratic. We can also find other factors. So what are we going to do? I think this one you can use the product in some method. So we're going to set the product in this case. This has a coefficient of 1 and we have a negative 2. So our product will just be negative 2. What about the sum? The sum will be 1. Two numbers that we can multiply, they'll give us negative 2. When we add them, they'll give us a 1. So 2 and a negative 1, right? They'll be able to achieve that. So in this case, our factors will be, so our factors for this expression will be, we have x minus 2, we have x plus 2, and we have x minus 1, like that. So these will be our factors. But if they ask you to find the range of opposite x values, you just equate all these ones to be equals to, so just equate these to be equals to 0. So x in this case will be equals to 2, x will be equals to negative 2 and x will be equals to 1, like that, if they ask you to find the range of all possible values. Okay, let's solve another question. We are saying the polynomial that is divisible by x minus 1 and leaves the remainder of 10 when divided by x plus 1. Find the values of p and q. Okay, this is just like the question that we just solved. Okay, since they've said it is divisible, meaning the remainder is 0. Okay, so the remainder is 0. So let's get the factor. We are saying our factor in this case is x plus 1. So because it is linear, we're just going to equate it to 0. So our x will be equals to 1. Then the remainder is equals to, let's say, p of x. Now we're saying the remainder in this case, because this is a factor, the remainder will just be 0. Okay, is equals to, in the polynomial, wherever there is x, we're going to be replacing by the one that we found here. So let's just do that. So we have 1 to the power 3 minus 2 1 squared plus p, okay, yes, minus a q. So what are we going to have? We have 0 is equals to 3 multiplied by 1 to the power 3, that is just a 3. 2 multiplied by 1 squared, that is just a negative 2, the way it is, plus p by 1, that is just a p minus q. Okay, what can we have? So 0 is equals to 3 minus 2, that is just a 1. Is it 3? Yeah, is it? Yeah, 1 plus p minus q. So let's which one can we make as a subject? Okay, let's take q the other side to make it the subject. So we have q will be equals to 1 plus p. This will be equation 1. Okay, we're trying to find the values of p and q. Now how do you find the other equation? They've given us a condition here. It leaves, if this expression is divisible by x minus 1, it leaves a remainder, and leaves a remainder of 10 when divided by, okay, when it's divided by x plus 1, it gives us a remainder of 10. Okay, so let's also solve using that condition they've given us. So in this case, we're going to say the remainder is equals to px, right? Okay, now we've told us the remainder, it gives us 10, right? Is equals to then what are we? It's x plus 1, right? So x is equals to negative 1. So wherever there is x, we're going to be replacing by negative 1 in the expression. So we have, in this case, we've got we have 3 negative 1 to the power 3, okay, minus 2 minus 1, this is squared, plus we have p, allow me to write it, let me just rub here. Okay, so we have p, there's a negative 1, okay, then there's a minus q. So what are we going to have? Negative 1 to the power 3, that is just a negative 1, and that multiplied by 3, that would be a negative 3. Negative 2, negative 1 squared, that is just positive 1, minus multiplied by negative 2, that is just a negative 2. P multiplied by negative 1, that is negative p, and a minus q. So how do we solve this? Negative 3 minus 2, that is a negative 5, and we have negative p, negative q. Okay, we can also make q the subject. We'll take it the other side, it becomes a positive. Okay, when we do that, what are we going to have? We're going to have another expression where I say q is equals to, we have negative 5 negative p. Okay, so this, let's call this one equation 2. Let's call this one equation 1. Now that we've got two equations, what are we going to do? Let's solve them simultaneously. Okay, let's solve them simultaneously. Okay, so what are we going to have? Let's get the first one. Q, or the second one, Q is equals to minus 5, actually it's minus 5 minus P. Okay, then our Q also found that it is equals to that, so what are we going to, we're just going to replace by that, so it will be 1 plus P is equals to 1 plus P is equals to, let's say 1 plus P is equals to negative 5 minus P. Okay, so what do we do? What now do we do? We put the like terms together, so we've got P, when we took the other P on the other side, becomes a positive, so of plus 2P, so of plus 2P, so to be plus P actually is equals to, this is negative 5, when we take the negative to the other side becomes positive, so we'll have the positive, when the 1 goes on, it will be negative. Okay, negative 1, so we have 2P is equals to negative 5 minus 1, that is just a negative 6. So our P in this case will just be, negative, it will be, when you divide by 2, that will just be negative 3. Okay, that's what we're going to have. Now how do you find our Q? Q is equals to negative 15 minus P, okay, which is negative 15 minus our P is negative 3. Okay, so negative 15 plus negative 15 plus 3, that will just give us like so our Q in this case will just be that is negative 15 plus 3, that is just like a negative 12, like that. Okay, so this is how we solve polynomials.